Now next question is a highly important and a very conceptual problem. We are given that a coin is tossed m plus n times where m is given to be greater than n, and we need to find the probability of having at least m consecutive heads. Now in order to get started with this problem, let us say the probability of a head coming is half, which is equal to probability of a tail coming, and probability of either a half or either a head or either a tail, let us represent this event by x. So probability of x is equal to 1. Now if the series of this m consecutive heads start from the first throw, then let us say we have head m times, and then x for the remaining n. This x can either be a head or a tail, which we assume our event in the beginning. We got to have at least m consecutive heads, so we have assigned at least m times the heads in the first m tosses, and then we could have either a head or a tail. If there are more heads, then it will make more than m consecutive heads, but we have at least m heads, so our case is satisfied. Or we could have a tail over here. So this is equal to half m times, and this is equal to 1 n times. We need at least m consecutive heads, so we have assigned the first m places by the m heads, and then we could have anything, a head or a tail, it doesn't matter. So this is equal to 1 upon 2 per m into 1. Now if the series of heads starts from the second throw, then we will have a tail in the first, and then head m times, and then we could have anything, a head or a tail, it doesn't matter, for the remaining n minus 1 times. So this is equal to half, and this is equal to half per m into 1. So this becomes 1 upon 2 per m plus 1. Now let us generalize our result. We have seen for the first throw, for the second throw. Now let us see that if the series of consecutive m heads starting from the r plus 1th throw. So for the first r minus 1 throws, we could have anything. Then we got to have a tail, because the head is starting from the r plus 1th place. This is the rth place. So r plus 1th place, the heads are starting. So these are heads again at m places, and then we could have again anything for the remaining n minus m minus r places. You should understand this thing, that if the heads are starting from the r plus 1th place, then we should have a tail in the rth place, and then before this rth place, the r minus 1 places can be filled by anything, either a head or a tail. So this is equal to 1 par r minus 1 into half par m again, and then 1 again for the remaining n minus m minus r places. So this again comes out to be 1 par 2 plus 1. Hence we have seen that whether we start from the second, third or r plus 1th place, our probability of getting at least m consecutive heads always comes out to be 1 upon 2 par m plus 1. Hence the desired probability is the probability of the event that a head is starting from the first place, which is 1 upon 2 par m plus 1 upon 2 par m plus 1, that is the starting from second place, third place, fourth place, these are n terms. Again listen, this is the probability of the series of heads starting from the first place. This is the probability of heads starting from the second place, third place, fourth place, and this is the nth place. These are n terms, or rather this is the probability of heads starting from the n plus 1th place. This is the second place, third place, fourth place, and this is the probability of a head coming in the, or the series of heads starting from the first place. So this is equal to 1 upon 2 power m plus n times 1 upon 2 power m plus 1. So this becomes 2 plus n upon 2 power m plus 1. Hence in this problem, which was a very important problem, what we did was, we split the entire problem into several cases. The first case was that the series of consecutive m heads starting with the first place, then the second place, third place, and hence the n plus 1th place. So our final answer is n plus 2 upon 2 power m plus 1.